I'm John from Hop Hog, and here's Hop Hog. I bought this house in 1990, little cottage on 3.5 acres in the middle of Long Island. And the thing I liked about it, of course, was the size of the property, not the house. Although I did make myself at home there for 30 years. Bought it in 1990. And the other thing I liked about it was that it had native soil. I mean, everybody talks about native plants, native birds, native mammals. But I think that another thing that we should start to pay attention to is the soil itself. So much soil is being adulterated or contaminated or mixed in with compost and other materials or covered over that soil itself is something that should start to be recognized if you're going to set up or revive a native habitat, especially with the plants, just like Andy had talked about. You know, there's problems with acidification and things like that taking place. So this had basically the original soil on it. And as a result, when I started to remove some of the non-native plants or ornamental plants that people had spent time planting before I was there, I was able to see a lot of these native plants, trees, bushes, flowers, ferns, coming up on their own from the soil. This is one of the plants that I had first seen coming in after I got rid of my lawnmower. This was, you may recognize as butterfly weed or milkweed, but another common term that you can use that it should be used more often is monarch flower. I don't see why we should still be calling this a weed. It should need a better status than that. So I call this orange monarch flower. And this was one of the first ones I saw, so I just let it grow because it was just a pretty native plant. I'm not thinking much more about it. Here's most of these photographs I took. If I didn't take them, I'll put photo credit down on the slide. You can see the monarch butterfly here. And this was taken out in Riverhead. So this is who we're going to be talking about today. At the time that I bought this house and started to welcome back the native vegetation, I noticed some butterflies coming around, and I knew just as much as any common person knew about butterflies. I knew the white cabbage butterfly and the monarch butterfly. I could identify them. But that was about as far as it went. And I saw a monarch butterfly here in one of the areas I was trying to revive. And there he was hanging out on a leaf. And I didn't know what he was doing, just probably resting or finding a spot, but it was kind of close to me. And I went to see what was going on. I looked on the other side of the leaf, and I saw eggs. I'm thinking, why, that little son of a gun was laying eggs. I mean, now that you know, take a better look and watch. You can see him depositing the egg right on the leaf. So that was one of the first things I learned about a monarch butterfly that was different from the common fact that, oh yeah, monarch butterflies, they migrate to Mexico, and that's about it. Their numbers are dwindling, they're affected by predators and pesticides. So now I realized, holy mackerel, look at that. Now I've seen a monarch butterfly lay an egg. And they also laid it, this happened to be on the Asclepias tuberosa, the orange monarch flower. And then I saw them again in another place on the seed pod itself. And got some close-up shots of that. And later on, I saw a couple of these hanging around. When I was younger, I used to squash tomato hornworms in my yard, and then I realized when I saw this, I'm thinking, gee, I hope they weren't monarch caterpillars that I was squashing at the time. Okay, so now, I became familiar with the caterpillar. All right, very nice. And then the next thing I knew, a day later, I saw this. I'm thinking, man, isn't that fascinating? We went from a butterfly to an egg to a caterpillar to a chrysalis. I mean, this insect couldn't make up its mind what it wanted to be. So this was in 2012 now, where I took some of these pictures, and Hurricane Sandy came along, where this chrysalis was hanging out, and knocked it down. And right around, well, the chrysalis is in there. All right, I'm not going to waste time looking for it, but anyway, I got a closer look. And son of a gun, if that chrysalis still wasn't hanging on that leaf. But the plant was down, I didn't know what to do, so I cut it, I brought it in my house, I put it in a glass jar on a windowsill. I figured, well, maybe I've got a chance of something happening here. And sure enough, I could see something happening inside the chrysalis. Again, I was just learning some of this firsthand for the first time. And then after a couple of weeks, I had read, well, the chrysalis should produce a monarch butterfly in about 10 days to 2 weeks around there. This was 3 weeks. I says, all right, so much for that idea. This thing's just rotten inside the thing. Before it starts smelling, I ought to get rid of it. I went to work. I came back in the afternoon. I saw this. And I'm like, holy mackerel, this is just too fascinating to overlook. I'm thinking, there's got to be more to this. And this really got me going. I'm thinking, look at this. This is just so incredible, how one animal doesn't go from something big to something small. It just keeps changing all over the place. And I really, this was in the early 2012, where I just really became obsessed with wanting to know, how does this happen? What's going on? How does it go through these changes? Why does it go through these changes? And does this produce a schizoid personality in an insect? Here it is. After it turned into the adult phase, I just carried it out of my house. Don't look at the condition of the house, please. And I brought it outside. I didn't want to touch it. I don't believe in handling butterflies. Some people like doing that. I don't, because I had looked at the scales on a butterfly wing that I found on the floor, and after it, I saw all the scales on my hand. And those scales are very important, especially for a migrating butterfly that's got to go thousands of miles. It needs as much insulation as it can get. So anyway, here's the butterfly, and I watched him climb up, actually her, to the top. And the other thing I like to do is call this an insect. The butterfly is an insect. And I like to use that term a lot because a lot of it helps the connotation for insects. I think in general, when someone mentions insect, the first thing they think of is some sort of an aerosol spray. If you start calling the butterfly an insect, you can help improve the connotation or the impression of insects. And here's a close-up of this insect in its adult form. And just a few things that you can start to notice right here is that it's, as an insect, it has 6 legs, right? 1, 2, 3, 4. Let me look at my notes. No, I'm just kidding. Right here is the third pair of legs, very short legs up front. And we're going to take a look at that as we go later on. So it does have 6 legs. 1, 2, 3, 4, 5, 6. So here it is. You can tell it's a female. It doesn't have, the males have little patches right here, which are the pheromones. So after that, I became interested in two items, two kingdoms that actually had a very close relationship with one another, the plant kingdom and the animal kingdom. The plants were the Asclepias species, and the animal was the insect, the monarch. They seemed to have something in common. There was some coevolution that went along because you found a relationship between these two plants, these two organisms. So here, just take a look at the antenna. Watch the antenna here. You can see the proboscis going in and feeding on the nectar, but watch those antennae. You see them? They're very active at a time like that. The monarch butterfly actually finds the Asclepias species with its eyes first. It's got these nice big compound eyes, and it's got a very broad range of vision for wavelengths. It can see more colors and wavelengths than we can, and more colors and wavelengths than bees can as well. So they can actually pick up the long wave ultraviolet light as well. And with their antennas is where they have their sense of smell. So they're actually checking, if I play this again, they're checking to see with their proboscis, they're sipping the nectar, but then they're checking with their antenna to see, is this flower worth going into? Is there any nectar in there? And with their feet, there's little receptors on their feet that are actually tasting for sweet, which is part of the nectar. So they can identify the Asclepias species before they even land on it by the wavelengths that the Asclepias species is given off. This is a leaf of Asclepias, or the monarch flower. And under ultraviolet light, it gives off like a red tint. Bees can't even see this. So it can tell from the color spectrum, okay, that's Asclepias, I'm going after it, and they lay their egg on it. Here's the monarch butterfly itself under ultraviolet light, and you can see the fluorescence there, and it makes you wonder whether they can identify each other and their own species from the wavelengths of the ultraviolet light itself. There's the egg. As fragile as that is, if you just touch it, you'll smash it. But you can see the corrugation on it, which actually gives it its structure. If it was just a round ball, it would be even more fragile yet. As soon as the larva hatch out of the egg, the first thing they'll eat is the eggshell itself because there's a lot of nutrients in it. It's a nice, quick, cheap meal. And if there's another egg around, they'll go and eat that eggshell. So for that reason, the adults try to spread out the eggs. They don't really want to lay them all. Remember, these females are flying around. They're like a carton of eggs flying around looking to deposit these eggs. The more they spread them out, the more the survival rate is going to be. So what happened was, fortunately, I mean, I've been promoting the Asclepias species on my property for 20, 30 years. And this last year, there was such a flush of Asclepias that I had, any butterfly that came around had a broad choice of laying eggs. So I had eggs and larvae all over my property this last year. And because of that, I was able to get a lot of photos and videos that I'm going to be showing you today. So last year was my bumper crop. This is on the other side of underside of a leaf. You can see that little 1 or 2 day old monarch butterfly is barely holding on. The underside of the leaf has these leaf hairs or trichomes on the bottom of it. And it's kind of like a protective mechanism that this particular species has. Plants really don't want to be eaten by animals. They go through a lot of work. They go through the trouble of photosynthesis to make sugars and foods and nutrients for themselves. The animals had a different idea on life. They went and they just ate the plants. And the plants don't really like the idea, but they contend with it. So one of the defense mechanisms they have two defense mechanisms. One is an herbicide. They produce natural herbicides, which is these chemicals, to try and make it distasteful or make it undesirable for an animal to eat it. And they also have these little leaf hairs on the bottom. You can't really make them out. Well, right here, look, you know, you can see right here these little leaf hairs underneath to make it difficult for the small little insects to walk around. But what the monarch, the larva here of the monarch, says, that's all right, I can deal with that, and it just grazes it. And it eats the trichomes themselves, which is supposed to defend the plant. I'm going to throw in some predators as we go along. Some of you may recognize this as the larval form of a ladybug. And they'll go and eat the eggs of the monarch butterfly as well. So here we are. Now it's maybe about 2 days old. And what it does is, after eating some of the leaf hairs in an area, it's getting a little bigger. Now it's ready to munch on the leaf itself. It's cleared this little pasture ground for itself. And one of the first things it does, it wants to nip these veins where all that latex is coming in, because it's going to get stuck to that latex, and then the game's over. So it actually goes to builds a little moat around itself so it can feed on the leaf there itself. Here's an interesting thing. The plants produce these herbicides to kill other plants, but they also produce herbivoricides to keep the herbivores off, the plant-eating animals and insects. So, and it works. However, somewhere along the line came the monarch butterfly, and it decided it liked the taste of the herbivoricide. I'll take some of that. And it didn't affect it. So we have a bit of a paradox here. Now you have an insect that's eaten the plant poison that's supposed to deter it. It's eating it. Not only is it eating it, it's making a preference to go after that particular plant altogether. And I'm sure the plant had a discussion with itself after realizing what was happening. These cardiac glycosides, or cardenolide glycosides that it produces, the monarch butterfly larva was actually ingesting and storing in its body. It wasn't even excreting it. It was holding on to it. So now this insect robbed the cardenolide glycosides, and now it has it. Here's a harvestman, an arachnid. They'll go and eat the eggs and the little larva as well. So here you have, it's starting to get a little bit bigger, and it's got its nutrition from the Asclepius, and it's also got these toxic metabolites that the plant has produced. As it gets bigger, like any other insect, it goes through its molting stage because it's got the exoskeleton on the outside. It's just like the clothes we wear. It's a very thin veneer, the exoskeleton. It's not like a bony, hard skeleton like we have, especially in the larval stage, because it's got to grow. It's more like a balloon. So it's growing inside this little balloon. As it's big enough, it actually crawls out of it and leaves it behind. One interesting thing about this is that how do you just walk out of an old shell? It's not really that simple. Of course, that's got to split a little bit, but it's got to climb out of it. But you have to set up some kind of attraction. You can't just walk out of it. It's got to get that shell caught somehow so it can pull itself out. And what it does is it actually puts down a couple of little fibers of silk and attaches it, and then the silk is stuck to the leaf, and now it can walk out. Wasps are another predator that come after these eggs and larvae. Here's a larva in the common monarch flower or violet monarch flower. And here it's now a pretty good size, maybe a ½ inch, 2 inches. I kind of like this close-up where you can actually see how this larva is pretty serious about eating up this plant. So it's filling up. Now here's the interesting part. The thing that I just couldn't really wrap my arms around was how does a caterpillar turn into a butterfly? How does that happen? And you'll see later on where you can actually see, if you have a backlight on it, you can actually see the butterfly forming in the chrysalis, but it just seems to happen so quick. The butterfly is already forming inside this caterpillar. It starts ahead of time before the chrysalis. So by the time the caterpillar is ½ inch long, you've already got the framework of a butterfly inside it. So this butterfly is wearing that coat. So, you know, when you see something like this and you see this thing eating, well, you figure, oh, yeah, okay, it's eating. There's the mouth that goes through the intestines and out the posterior orifice. That's it, finished. Just a straight tube. No. There's a butterfly forming inside that. The framework is being formed. They also eat the flowers. On my property, when I walk around and I see all these leaves with holes and flowers eaten up, I'm thinking, yeah, that's what I want. I want to see that. I mean, you get to see your flowers, but you know you've got insects eating there. You want the insects. Without the insects, you pulled out a whole chunk of the food web, and you've pretty much disengaged your whole ecosystem. So now, you've got the larva full of all of these toxic compounds. Some of the other insects can tolerate these toxic compounds. So invertebrates, as I showed you, are predators, and those are the dangerous predators of the monarch. But the vertebrate animals, they eat at one time, and then they get sick to their stomach, and they vomit it. You can see this is a monarch butterfly, a blue jay eaten. After I said, man, I'm never doing that again. So it usually takes them one time to learn it. Other butterflies see this happening, and so they develop they mimic coloration. They said, I'm going to grow the same color wings as this guy. So you've got like the viceroy butterflies also. So they're pretty well safe because of the sacrifice that this monarch did. Here you see the larval insect. It does a pretty efficient job of stripping down a tree, or a bush, I should say. This plant is pretty well stripped down. You can see the droppings of it getting larger and larger, along with the larva, and the plant getting smaller and smaller. This also shows that paradox. Here's a plant that's putting out all of this toxic compound, and the more toxic compound it's putting out to keep insects away, the more insects come to eat it, or at least this insect anyway. This is one more predator that I'm going to throw in. This is the praying mantis. This is the native one, Stagmomantis carolina. This is the native praying mantis. Unfortunately, a lot of people think, oh, praying mantis kill harmful insects. So they go and they buy these praying mantis egg cases. A lot of them are the Chinese. The Chinese praying mantises are bigger, stronger, and more aggressive. And they will go after monarch butterflies. I don't know if you can make this out, but here's the praying mantis. There's the head, there's its wings, the green wings, and there it is tearing apart a monarch butterfly. So it's really not recommended that you go and buy these praying mantis egg cases, especially if it's not known that it's a native or from Long Island. And of course, no good presentation on the monarch butterfly would be complete without mentioning our friend Roundup. Glyphosate, I'm just going to mention that not only, it's touted as an herbicide. Glyphosate, and that's how it's categorized. This is an herbicide, it kills plants. But that's a very incomplete description of glyphosate. Glyphosate also kills bacteria, and along with those bacteria are soil bacteria and the bacteria in the intestinal organs of us and other mammals and poultry. So if you incapacitate or change the internal microflora of bacteria in an animal, you're creating a scenario for a whole variety of maladies and sicknesses and cancers in animals as well. So Roundup has been largely attributed to the fall or the decline of monarch butterflies, principally because it's now more efficiently wiping out the Asclepias in the west and the breadbasket area, where they're growing the corn, the soy, in the Midwest. So now comes time, last summer comes along, and now I have I see all these butterflies laying all these eggs, and I got my photographic equipment in order. I'm thinking, okay, now I'm ready. So just to get a little view of what's coming up, here's the head of the larva. This is what we're going to be concentrating on right now. This area in the head, the spinnerets, that's where the silk comes from. That's where it extrudes its silk. A couple of other little features. You've got the eyes. These are the eyes, which are kind of pathetic, which it probably doesn't really make much use of. These are the antennae, not those big tentacles that you see going around. I used to think that those were the antennae. No, those are just sensory organs. Here's the antenna here. These are the antennae. And then these are just maxillary polyps, which help guide the food into the mouth. And this is the mouth right here. Here's your mouth. So here we go. This is the first video. Ready? One of the big questions I had, which I looked on the internet, and the thing that kind of turned me off a little bit was when you see these videos on the internet, usually they're taken in a lab, in someone's room, on a screen door, in a jar, and I figured, all right, that's good. I got the idea now, but I want to see this happen out in nature. How do these things actually take place out there? I got the idea, but I want to see it for myself, these things that are said to happen. My first question was, okay, how the heck does that thing hang from a leaf in a jay? And I couldn't even figure out when I was first looking at it. They've got these tentacles by their head. But then just to throw you off, they got tentacles down here too. So when this thing's hanging upside down in the jay, is it holding on by its mouth? Which way is up, which way is down? How is it even hanging? I couldn't even see anything. It was just by a little point just hanging there. How does it do that? Is it upside down coming out, or is that its head, its mouth, and then somehow it climbs out of its mouth? I mean, what's going on here? So I set up my cameras and I sat, and I spent last year sitting next to insect larvae. This is the first thing I saw. Okay, here we are on the underside of a branch, and you can see the spinneret right up at the top where I showed you. See him, he's checking the strength of that attachment right there with one of his legs. So there, he's laying the silk on the underside of the branch. The first thing they do is, if they're going to attach, he puts a big, he spreads his silk, all of this here, see all this glistening? He was all over here spreading this silk for a couple of reasons. If he's going to do some work, or she, underneath a branch, they don't want to fall off. So first you put a netting of silk. You've got something to grip onto. And the next thing you want to do is create this little mound of silk here. And you want that, you don't want that little mound of silk falling off. So that's all attached to this whole network right all along here. And I just sat and I couldn't believe what I was seeing, because, you know, now I'm really up close on this guy. And you can see it diligently and patiently making this little mound of silk. So, got it for, I'm going to show you these. These are not all of the same larva. You know, I had so many going on, so I could get different angles and different stages from the different monarchs that were there. Here's another one. You can see the same idea where it's building the silk, but it's going and stretching it all over to make this thing so tight that you got to pull that tree or branch down before the thing falls. Now I understand why that chrysalis that was blown down from a hurricane wind couldn't knock that thing loose from that leaf. And this is why. So this guy's busy. Okay, so now I got the idea. He lays silk and he makes that little mound. So now I know, okay, so that's how it attaches to the underside. But still, all right, so now what? Is he holding on by his mouth? Is he holding on by his rear? What? So now he's pretty much finishing up, just tying things up now, or she. You can just assume that I'm saying or she from that one, so I don't have to keep saying that. So now I'm waiting to see, okay, what are you going to do with this thing? How are you going to grab on? What it does is, after it does this, it turns around and heads away from it. Okay, I got that idea. Now, I don't know, is it still laying silk? It seemed like it stopped laying silk. Now, if you just started the video now, you would think that this is the head up on top. I mean, they kind of look the same, you know, but this is the posterior end of the larva. And that posterior, there's a lot of sensors there as well. This is going to go on for 4 minutes, so you can watch this. I'm just going to go out for a quick smoke. And I'll... So you can see the posterior end trying to search for something. Takes a little break every once in a while. I like to show this in real time. I mean, I could have done it in time lapse, but it kind of, you lose the whole sense of what's going on here. You can see the patience of the caterpillar. Okay, so that rear end is actually, doesn't it look like the head? Could be, right? Yeah, it's got those tentacles just like the front. It's probably just to confuse a predator or something, I'm presuming. But and you can see the antenna busily vibrating on both ends. So now the front end talks to the back end. I don't know what they said. Now, a couple of things to notice here. You've got these, oh, you've got to be kidding me. I'm so sorry. Oh, shoot. There's no way of speeding this up either. All right, putting that down. Notice these are proto-legs. They're not the real legs. They're going to disappear. The real legs, the three pair of legs for the caterpillar are actually up front here. These legs disappear. Oh, there. Okay, see these three? That's in the thoracic segment of the adult butterfly. These here are only temporary feet. And all the way in the back, same thing. The pair of proto-legs, or early legs, those are going to leave. But it's that last pair of legs that have not just pincers on them. They're not only can they clasp, but they've got little spikes or thorns on them. Really, really, really fine. Actually, this is good to see. This is how I was all last summer, on the floor, sometimes falling asleep and missing what I wanted to photograph. I mean, because, a couple of reasons I wanted to stay right there with it is because predators could come by, wind could come. I mean, anything can happen. Your battery goes out. And I used my phone a lot, actually, to take a lot of these videos. So if you're taking a video, I learned the hard way with a phone, especially when you're sitting waiting for something to happen like this, and the phone rings, it shuts your video off. And that has happened. So, you wish real hard that nobody calls you when you're doing this. Am I good?
No, you're good. You're at 45 minutes.
You're giving me another 45? Oh, I'm at 45?
Yeah.
Okay. I'm going to have to pass. All right, I'm going to have to pass through this. But anyway, it attaches from here. This here is the, just showing how at the back end of it clasps on to this, this silk button. Here it is. Actually, so now we know this is the head on the bottom, and that's where it's clasped on, up on top. And then you can see the butterfly that's inside there, already there. This here is a disguise that it's wearing when you're looking at the caterpillar. The butterfly is in there, and you can see it vibrating, or undulating underneath to try and break that jacket that it has off. And that's where it starts to split down at the bottom. Now, this is outside that I got this. And it starts to split, and you can see, actually, before the chrysalis actually takes its shape, you can see the segments and everything of the butterfly itself. So this here splits all the way to the top. And this is showing the cream. This is a micrograph of the end of that not this other structure that it actually pushes up into the silk, and this is what it looks like, almost like a Velcro type of a thing. And then there is your early chrysalis, and then after a while, the butterfly, now this is also another jacket. This is now its new jacket. The butterfly is inside now this new jacket with this new exoskeleton. And then it turns into it wiggles around a lot. There it is. You can actually see, this is a 2-day-old chrysalis where you can already see the wings. So that's showing you that this was already forming. And they'll go in grass. Here it is, you can actually see right here on the outside. This is the antenna. Here's its proboscis. You can actually start to see right through the chrysalis. And here's some ants coming along, eating one of them. And so this is the main event right here. This is the chrysalis that I sat the most with during the day, at night, and I stayed up all night because I figured so many times you come out in the morning and there's the butterfly. It says, oh, no. I'm staying right here with you. So I stayed with it, and then you start to have these weird dreams, you know, if you're staying up all night. And then finally, here you can see this thing's ready to go. I'm late for work. I said, forget it. I'm going to be late or I'm not going. I'm staying right here with this thing because I know this is going to happen. So there it is hanging. This is early in the morning, last summer. And here's the video, and I'm just going to break the law, and I'm going to let this video run. This is the end. I think. Come on, get out of here. Okay, you can see that. Yeah, very funny. You can see it's starting to move. So this is outside in nature. Not far from my front door. Two things to watch for when this comes out. First off, this guy's got to watch that he doesn't fall. So he's got to do a quick trick. And the other thing is, watch, as soon as he comes out, the proboscis was in two pieces. He's got to actually push those together so that he has the single tube. It's actually formed in two. So watch that third pair of legs, those little legs, that's one of the main things that they do, is to try and put together and piece together those two pieces. So watch up by his head once he gets out of there. See him putting it together? He's got a couple of things she's got to do. Hold on to that thing. Don't fall. If it falls, it's dead. Not because it dies, but because the wings right now are, see him putting it together? He's piecing together that long loop. That's his tongue, or proboscis. And she's hanging on. Actually, that is a she. If it falls, those wings, which are now wet, will crease, and it won't be able to fly. Okay, and that's that. I'm just going to, there you can see it. And here's another one, a different one I have over here on that log coming out. It's out. And here I have, all the way over here, this is the last thing I wanted to get, was the maiden flight of a butterfly. It just came out of here, and I sat and I watched. I wanted to get the maiden voyage. There we go.
All right, thanks, John.